All right, guys, this is going to be the lecture for homework 16. Remember, I said after 15 we'd be heading back into graphing. So it's what we're going to end up with here. We're not going to start with graphing. Homework 16 is primarily solving equations. So that should be good news. You should have some recollection of this from high school. Maybe it was a while ago, but you know, you've done it before. Which will eventually lead into graphing. Sorry, I don't know what I just said, but that's the idea. We're going to be solving equations, but ultimately the point is to bring it back to graphing. So there will be solving on the test, but ultimately, you know, again, the idea here is graphing. So when we say solving equations, you know, something real straight up and, you know, familiar to you, hopefully, something like 2x equals 4, right? And the question is to solve it. Not simplify, remember, because we have equations, you know, having equal signs. So what I'm asking you here, and this one you can probably do in your head, I'm saying what is 2 times some unknown number, and that makes 4. So what is this unknown number, x? 2 times x makes 4. So you're probably sitting there screaming that x equals 2, right? Because if I put in 2 for x, 2 times 2 is 4. It makes both sides true, and we have our equation solved, right? So that's what we're talking about, solving equations, getting x on one side, getting your number on the other, and that's what your answer should look like. We obviously will be doing problems that have a little bit more depth to them than 2x equals 4, but just to give an example, so these steps I'm about to write out are my suggestion. There really is only one rule for solving, okay? And that rule is what you do to one side, you already know what I'm gonna say. What you do to one side, when I say one side, think about what I mean. One side of what? What you do to one side of the equal sign, you must, and this is the key, do to the other. This is really the only rule. As long as you do what you do to both sides, you're not ever going to be wrong. It may not be getting you toward the answer, though. You can do some things that are sort of pointless. They won't make the problem wrong, but they certainly won't help. So, for example, if I said 2x equals 4, and for whatever reason I decided I'm going to add 5 to both sides, there's no reason to do this. So don't write this down like it's the correct step. I'm just making the point that it'll still come out. 2x plus 5. 4 plus 5 equals 9. And now you can still solve this, and the answer is still going to come out to be 2. Think about it. If I plug 2 in here, 2 times 2 is 4, plus 5 equals 9. So the answer is still 2. Because I added 5, I did it to both sides. Even though it was sort of pointless, it still will give you the same answer in the end. So this is the only rule that we need to be concerned with. What you do to one side, you must do to the other. What I'm about to write is my suggestions in terms of how to do these things. Like try doing this first, then this first, then this first. It'll make life a lot easier, but these are not requirements. These are simply suggestions. So keep that in mind. If you already know how to solve or you have your own way to do it, that's not a problem at all, as long as it works out. First step, just like when we were simplifying in the last homework, I would tell you to distribute, if possible. In either case, we had up here 2x equals 4, or the more advanced 2x plus 5 equals 9. There was nothing to distribute, so that's why I said if possible. Second step would be clean up, and I'm going to say / simplify, right, because we talked about that, each side. And again, remember, when I say side, I'm talking about the sides of the equal sign, right? What I mean by this is take a look at the left side, 2x. Can you clean that up at all? No. Take a look at the right side, 4. Can that be cleaned up at all? No. Right? But if we come over here, 2x plus 5, can that be cleaned up? Well, no, don't fall for it. Remember, 2x and 5 are not like terms. They would not add together. The other side is just 9. So when I say clean up or simplify each side, I mean if on one side you had 3 plus 5, you might as well just call that 8. You'll see what I mean as we go. Third step, and really the main step here, get x's, and obviously you know it does not have to be x's. It could be whichever variable you're using. Get x's on one side. And then we call it's really step 3. Get numbers on the other. All right? Get the x's on one side, get your numbers on the other, and then you will have your solution. How do you do this, though? And that's the key point. How do you move x's around? You undo things. You undo plus with minus. You undo times with divide. All right? So let's just take that real quick. Take that example we just had, 2x equals 4. You already know what the answer is, but let's go through the steps just to show how it works. Can we distribute? No, there's nothing to distribute. Can we clean up either side? No, 2x doesn't clean up and 4 doesn't clean up. So in both cases, these steps were done already. Next one, get x's on one side. That's already happened. We have our x's on the left. That's great. So that part's done. It says get your numbers on the other. So what we need is to get the 2 over here with the 4, right? We want our x alone on the left. We already got our x's together. Now we need to get the numbers away from the x. Collect your x's together, then get the numbers on the other side. So what we have here is 2 times x equals 4. How do I get rid of times? With division. So I'm going to divide by 2. 2 divided by 2 is gone. I'm left with just x. But what you did to one side, you got to do to the other. And 4 divided by 2 is 2. And there's our answer, which we knew it would be. But, you know, always better to start off with something familiar, right? So take a minute, write those steps down. I'm not going to rewrite them on every page. I will mention them on every equation we do, but I'm not going to rewrite all this. So if you want it, make sure you write it down as we go. Okay? Let's go ahead and step it up and get into some, you know, a little bit stickier problems. Most of the homework today is going to be just examples. You kind of have already gotten the notes. Now we just got to show how to do the different examples, you know, how to do it when it's a little more difficult. Let's say I said negative 3x plus 7 equals negative 5. And again, for all of these, the instructions are just going to be solve, right? Solve for x, solve for y, solve for b, whatever the variable is. So we have negative 3x plus 7 equals negative 5. For the moment, I said I wouldn't do this, but I'll do it here. For the moment, think about the steps and how you would do this. Is there anything to distribute? No, there's no distribution up here at all. Can you clean up either side? Negative 3x plus 7 does not clean up. Those will not go together. They're not like terms. And negative 5 is just sitting there by itself, so there's nothing to clean up. Third step, get x's alone on one side. That's already happened. The left side looks to be the side we have our x's on. We're going to move probably our numbers over to the right side. Okay? How, though? So we've got this negative 3 that needs to go to the right side. We've got this 7 that needs to go to the right side. Then the x will be alone. So that's what you need to think here. We've got negative 3x plus 7 equals negative 5. Well, all we need to do, steps 1, 2, and half of 3, we're done. All we need to do now is get the numbers on the other side. All right? So we got negative 3x and we've got 7. Think about what it is that needs to move here. The 7 needs to move away and the negative 3 needs to move away. Now, think about the order I suggested you do this in. I said get rid of plus and minus first and then get rid of times and divide. And I said that in that order for a reason. If you try to get rid of this negative 3 right now, what are you going to have to do? That'd be negative 3 times x. How do we get rid of times? With division, right? So I'd have to divide here, here, and here. When you divide, you're dividing everything. You don't want to divide 7 by 3. That's going to make a fraction. And 5 divided by 3 is going to make a fraction. I would strongly suggest you do not divide until the very end of this problem. When you're solving, generally speaking, division should be your last step. That's why I wrote it in that order. So we're going to go ahead and get rid of the plus and the minus first. I'm going to get rid of the plus 7 with a negative 7. Make sure you do it to both sides. If you want to, draw a little line down the middle. Some people like that. Totally up to you. Negative 3x, 7 and negative 7 cancel. That was the whole point. So now we have negative 3x. We got rid of one of the numbers. On the right side, negative 5 minus 7, that's negative 12. And now we're back to kind of a pretty basic problem. We got negative 3 times x equals negative 12. To get rid of times, you divide. Now be careful. This is not plus and minus, right? This is division and multiplication. When you divide to get rid of a negative, you need to divide by the negative. I want to get rid of the 3, and I want to get rid of the negative. Make sure you divide by negative 3 to both sides. X on the left. Negative 12 divided by negative 3 is positive 4 on the right. If you want to, you can go plug this back in. Negative 3 times 4 is negative 12. Plus 7 is 5. Excuse me, let me try that again. Negative 3 times 4 is negative 12. Plus 7 is negative 5, which is what it should be, so we know this answer checks out. You do not have to go plug these back in. On the exam, I don't know that you'll have time. It just depends on how quickly you work, how familiar you are. So let's call the checking step optional, just simply because I don't want you getting hung up on the test because you were trying to check every single problem, okay? If the answer is, 4 or 10, plug it in. If the answer is 2/3, which it can be, then, it is what it is, and you probably don't want to plug that back in. So let's try another one here. Let's try 9t minus 9. Most of these are directly out of your homework. Some of y'all were telling me you like when I do, well, obviously you like when I do the homework problems, but that they're a little more effective when I'm doing the ones directly from the homework. So that's mostly what I've pulled here as homework problems. So try this one on your own. Give it a pause and see what you can do. 9t minus 9 equals 6t minus 3. Give it a pause, see what you can do with this, and then we'll work it out together. All right? So first thing I'm going to do is think about, is there any distribution? No. Again, have those steps with you, right? Have this little checklist with you if you need to. There's nothing to distribute here, and there's nothing to distribute here, so I don't have to worry about that. Can I clean up the sides? Well, remember, what I mean by that is just look at the left side by itself. 9t minus 9, can that be cleaned up? No. Look at the right side. 6t minus 3, can that be cleaned up? No. These are not like terms. These are not like terms. We're good. So right back into step 3, which is get the variables on one side, get the numbers on the other. This case, though, the variables are on different sides and the numbers are on different sides. So which side should the variable go on? Well, most people use the left and they'll put the numbers on the right. And in fact, that's what I would tell you to do. Go ahead and put your number, your t's on the left and your numbers on the right. Okay? I'm actually going to do it a little bit backwards just to show you that it doesn't matter. This does not mean you have to do it like this. I'm going to go and get my t's together on the right and I'm going to put my numbers on the left. It does not matter. It does not matter whether it looks like x equals 4 or 4 equals x. So don't be afraid to pick whichever side you'd like. I'm going to go ahead and do it a little different. I'm going to put my t's together on the right side. If you did the t's together on the left, it'll look differently as we go, but the answer will still be the same. So for me, the way I'm doing it, I want my t's together on the right. So the first thing I'm going to do is try to get this 9t over here to join the 6t. How do I do that? Do I want to divide by 9? No. Remember, as I told you, division's often the last thing you want to do. Think back to this problem. We didn't divide until the very end. And if you divide it now, all you're doing is splitting the 9 and the t up. I don't want to break this apart. I want to move the whole thing over here. So wouldn't you agree that's a positive 9t? So I could subtract it. 9t minus 9t is gone. On the left side, we just have this negative 9 we didn't do anything with. Your equals sign is still there. You subtracted 9t from this side. 6t minus 9t is negative 3t. And then you still have this minus 3 we didn't do anything with. Again, if you're moving your t's to the other side, this is going to look very different. Once we get to the end, it will be the same. So now I have negative 9 equals negative 3t minus 3. My t's are together on the right. Good. Now I need to get my numbers together on the left. So this negative 3 needs to move, and that negative 3 needs to move. Which one am I going to get rid of first? Probably the plus and the minus. It's just a little bit easier. So to get rid of the minus 3, I'm going to add 3 to both sides. Watch your negatives here. Negative 9 plus 3 is negative 6. Equals, this is gone, so it's just negative 3t. Again, if you like that line down the middle, feel free to draw it. Now I have negative 6 equals negative 3t. I need to get t by itself, so I'm going to divide by negative 3. See, when you divide at the very end, that looked ugly. When you divide at the very end, it just comes out clean. It doesn't mean the answer will be coming out clean, but it's a lot less junk. If you divide early, you're going to have to divide everywhere and make a bunch of fractions. You don't want to do that. Negative 6 divided by negative 3 is 2. Negative 3 divided by negative 3 is gone, and that leaves us with t. So we have a nice clean answer of 2. Take a minute, make sure that makes sense to you, okay? I did mention fractions a second ago. There are some problems with fractions in them. Not a ton. I only saw a couple when I was flipping through, but we can talk about them because we can handle fractions. I think the one, let's see, what was it in the homework? It was 2/5 x plus 4/5 equals negative 2/5. Now, they're kind of going easy on you because if these denominators get different, this can get kind of difficult. But remember, the point here is not to put you through a solving gauntlet. The point here is for you to be comfortable with basic solving so that we can graph. So we're not going to be hitting you with the hardest stuff possible, but we do need to know how to deal with fractions. So think through the steps. First step, is there anything to distribute? Doesn't look like it. Second step, can you clean up the sides? Can 2/5 x and 4/5 clean up? No, they're not like terms, and the right side only has one number. So that cleanup step doesn't happen very often. So now let's think about this. I could move the fractions, right? Maybe take this 4/5 and bring it over here and do all that. You know me by now. I don't like working with fractions. I try to avoid them. I mean, I like them better than decimals, certainly, but I do not like them in general. So I want to get rid of them. Let's think about this. Aren't all of these being divided by 5? Isn't that 2 divided by 5 and 4 divided by 5 and negative 2 divided by 5? Well, how do we get rid of division? With multiplication, yeah? So let's multiply. Whoa, what is going on with the screen here? Hold on. This thing's having a stroke or something. Give me a second. I do not know what it is doing. It's like auto-focusing. There we go. Thank you very much. So what I'm going to do is I'm going to, instead of divide everything by 5, I'm going to multiply everything by 5. Fractions are just division, right? To get a fraction, you're just dividing. So to get rid of a fraction, just multiply. Just make sure you're multiplying by something that gets rid of all the fractions. And that's why I said in this case, they're all 5, so it's not too crazy. This light is really, really weird. I don't know why it looks like this, guys. Sorry. You might want to turn the brightness down. This just looks very, very bright to me. 5 and 5 cancel, and you have a 2x. Positive. 5 and 5 cancel, you're left with 4. Over here, 5 and 5 cancel, and we're left with -2. Go through and make sure you're clear on what I just did. 5 cancels with each. The multiplication of 5 cancels with the division, so you have just 2x left. The multiplication of 5 cancels with the division, so you have just 4 left. And the multiplication of 5 cancels with the division, so you just have -2 left. And hopefully now it's just like a trivial solving problem. Get 2x on alone, so we need to go ahead and minus the 4 from both sides, right? So I'd have 2x equals -6 divided by 2, and x equals -3. Hopefully this is starting to come back to you. You've definitely done this before. It just depends on how long, okay? Let's go ahead and do a bit of an uglier problem here. I do not know what is going on with the brightness. This looks ultra white. So yeah, if this is like blinding you, turn your brightness down just a bit. I'll see about adjusting this for the next video. So let's say we had 2 times x plus 5 equal, oops, excuse me, I wrote the problem down wrong. 2 times x plus 5 minus 6 equals 2 times x minus 4. Okay? What would we do with this one, right? This is a bit uglier than any of the other ones we've had so far. Well, if you remember the steps I suggested, the first thing I suggested you do is distribute, because this x plus 5 is locked away until you do. This x minus 4 is locked away until you do. So let's go ahead and distribute. You remember what that means from the last homework. 2 times x is 2x. 2 times 5, that's positive 10. Remember, we are not distributing to the -6 because it was not in the parentheses. 2 times x is 2x. 2 times -4 is -8. And now we have a problem, at least without parentheses, right? The next step was to clean it up, and now you're finally going to see what I mean by that. Look on this left side. We have 2x plus 10 minus 6. 10 minus 6, we can put that together, and they're already on the same side. So you don't need to add the 6 or do anything weird. This is just going to be 2x plus 4. Clean it up. The more pieces you have, the more things you have to move. If you can just put these pieces together and get a nice number out of it, do so. So the point here, guys, is if they're already on the same side, just combine them. You don't need to move them around or do anything weird. On the right side, we have 2x minus 8. Okay? So now we need to get our x's together on the left or the right. It doesn't matter. We'll go ahead and just do the left because that's what I think most people like. So I'm going to get this 2x over here with that 2x by subtracting. Now here's where people will think they've done something wrong, and you haven't done anything wrong. 2x minus 2x is gone. You're left with just 4. This is the truth. 2x minus 2x is gone. You're left with just -8. This is the truth. But then they say, well, 4 doesn't equal -8, so something's wrong. I did this wrong. I don't know what to do. I don't know what went wrong. You haven't done anything wrong. What you have arrived at is called a contradiction. 4 does not equal -8. And this is not 4x, right? The x's are gone. Notice the x is canceled out. 4 does not equal -8. That's absurd. That's a contradiction. So what this means, assuming you made no mistakes, I mean, if you goof something up here, then who knows what's happening. But assuming you made no mistakes, this is telling you there is no solution. It is possible for there to be no solution. How will you know you have no solution? You will end up with a contradiction. Your x's will cancel, and what you have left will be something that's just not true. 4 doesn't equal -8. 0 doesn't equal 10 or something like that. So watch out. Some of these have no solution. I mean, you shouldn't be finding this on every other problem, but if you find 1 or 2 in the homework that have no solution, it's probably correct. Okay? So let's keep going. Again, pause it, back it up if you need to. Rework the problem. That's the beauty of the lecture system online, is that you can take your time with it. Let's do, let's see, -3x minus 10 equals -7 minus 3x minus 3. Just another kind of long one here. Think about how you do it. Again, I would encourage you to pause it, do it yourself, and see what you get. First thing I'm going to do is say, is there any distribution? No, so I don't have to worry about that. Second step, can I clean anything up? Well, not on the left side. -3x and 10 do not go together. On the right side, though, we got -7 and -3. We can put those together. So we got -3x minus 10 equals -7 minus 3. That's -10. -7 and -3 are on the same side. You can just put them together. And you still have your minus 3x here. All right? So the next step would be to get the x's probably on the left with your numbers on the right. Again, which side you move stuff to is up to you. So I want to take my 3x over here. I'm going to add 3x to both sides. And this is where people will now make another mistake. They'll say, okay, 3x and -3x cancels. 3x and -3x cancels. My x is canceled, so this is no solution. That's not the case, because look at what you have now. You have -10 on the left side, and you have -10 on the right side. This is true. This is what we call an identity. So just because the x is canceled, in fact, let me write this down. Let's write this down. We have no solution. This is something that should not happen very often, but it can. When we have no solution, and that's the last problem we did before this, the x's will cancel. But also, you will be left with a contradiction. So your x is canceled, which they did, but you'd be left with a contradiction. We don't have a contradiction here. We have something true, so it's called an identity. 3 equals 3, -10 equals -10, or whatever. So that's all real numbers. What this is saying is that there, or the other way to say this is infinite solutions. Think about it. -10 equals -10 all the time, no matter what. So if this equals this, then this equaled this, and then this equaled this. You have the same thing on both sides the whole time. I mean, I know it's kind of a, you'd have to almost know to look at it backwards to realize that, but I am making the point. So how do we know the difference between when we have no solution and all real numbers? Because the issue here is the x is canceled on both. Go back and look at the problem we just did with no solution. My x is canceled out, right? 2x and 2x canceled out. But that doesn't guarantee no solution, because the x is canceled here as well. It's about the result. If you're left with a contradiction, something that is impossible, that's no solution. If you're left with an identity or something that is equal, that means there's infinite solutions, or technically speaking, all real numbers. So be careful. This kind of stuff can happen. It's not common. It's not something you should see all the time, but it can happen. Be aware of it, okay? And this is how you tell the difference. If your x is canceled or your variables cancel, you do have one of these. It depends on if you end up with something that's false or something that's true, which the answer will be, okay? So be a little bit careful there. You'll also notice in your homework sometimes that they'll ask you to solve things that have a lot of variables in them. Something like this. 2a, let's block this off. 2a minus 4b, or excuse me, good grief. 2a equals 4b minus c. And here they're going to tell you solve for b. Up until now, they haven't said solve for x or solve for y because there's only one variable. Obviously, you're solving for x here. There's no other variable. Here, there's multiple variables. These are sometimes called literal equations. The name doesn't really matter. You just get the b alone. Because remember, what does solving mean? Go back and look at every single problem we did. It says get the variable by itself. Let me pull up the non-strange ones here, right? What did we do when we solved this? We got the variable by itself, right? Anytime we solved anything, we got the variable by itself, we got the variable by itself. That's what solving means. Get the variable by itself. So when they tell me to solve for b, they're telling me to get b by itself, okay? So we got 4 times b minus c equals 2a. Think about what is keeping the b from being alone right now, because that's what we're trying to do. We're trying to get b by itself. We have 4 times b minus c. So that 4 needs to move. Oh, here it goes again. There we go. The 4 needs to move, and the c needs to move. Don't get rid of the multiplication first. Get rid of the plus and the minus first. So I'm going to add c to both sides. And here's where people kind of freeze up. Well, I don't know what 2a plus c is. That's the beauty. It's not anything. 2a plus c, those are not like terms. So it's 2a plus c. Quite literally, just write it. 2a plus c doesn't add together to make anything. So 2a plus c equals 4b. These are actually easier once you do them, because oftentimes the numbers don't work out. You don't have to worry about making a sign error because you can't combine these. They're easier once you get used to the way they look, right? Now, we've gotten the c over here, so the only thing we need to do is get rid of the 4. It's 4 times b, so I'm going to divide by 4 to both sides. So in the end, we had b by itself. And again, remember, you can switch sides of an equal sign. Over here, I have b alone on the right side. You can write it on the left. It doesn't matter. b equals 2a plus c all over 4. And you don't need to reduce it or worry about anything like that. We're not getting into all that stuff. All right? And that's called a literal equation. We're going to do one more because those are strange, and those are the ones people have a lot of trouble with. But all right, let's try something like this. A little bit trickier. F equals 7 over 2 times n minus 49. And the instructions here tell us to solve for n. Okay? Now, again, that means get n by itself. F is already by itself, so if we had said solve for f, we'd be done, right? So we need to solve for n. Now, here's the thing. You got to be smart about this. Can you distribute the 7 over 2? Yeah, you could. I don't want to, though. Aren't you trying to get n by itself? Why would you want to bring a fraction onto it and make it even worse? So what I'm going to do is get rid of the fraction first. Just because I don't like, I mean, just in general, I always will try to get rid of fractions first. So think back to the one we did before. This is 7 divided by 2. How do you get rid of division? With multiplication. So I'm going to multiply the left side by 2. I'm going to multiply the right side by 2. You only need to do it once, though, because you didn't distribute. This is all one piece. 7 over 2 times n minus 49. If you distributed, now it's 2 pieces. Now you have to do it twice. I don't want to get into all that. So this whole thing multiplied by 2. On the left side, 2 times f is just 2f. On the right side, 2 and 2 cancel out. And you're left with 7 times n minus 49. Again, this was 7 divided by 2. That's what a fraction is. To get rid of division, I multiplied. The multiplication of 2 and the division of 2 canceled, and it just was left with 7. So now I have 2f equals 7, let's rewrite it. 2f equals 7 times n minus 49. I want to get n by itself, so let's get rid of the 7 then. Because if I multiply the 7 to the n, then I'm going to have to get rid of it there, and then 7 times 49 is just going to make this number bigger. I'm going to divide by 7 and cancel it. Just make sure you do it to both sides. So now I have 2f over 7 equals n minus 49. The parentheses don't need to be there anymore because you've cleared them. There's nothing to multiply by. So now to get rid of it, or excuse me, to get n by itself, I'm just going to add 49 to both sides. Now don't panic here. This is where people start getting weird. 2f over 7, okay, plus 49. I don't know what that is. This is f. This is 2f over 7 and 49. These aren't like terms. They're not anything. It's going to be 2f over 7 plus 49. You can't combine those to make it anything cleaner. And on the right side, negative 49 and 49 canceled, and you're left with just n. Go through that one again and make sure you're comfortable with it, because that's the one, or these are the types that give people the most trouble, okay? Take a minute, look that over, and make sure that makes sense to you, all right? Now, the point of the homework, as I said when we started, is to get back to graphing, all right? So ultimately, that's the idea here, is that we're going to graph. Now, we're only going to do a couple of graphing problems, so I'm not going to bust out the graph paper like I do. But we will use it again, but for now, I'm just going to hand draw these because we're only going to do a couple. Because you know how to graph, you just took a test on it. What we want to talk about is how to graph with solving, right? Or how to solve with graphing, that kind of thing. So let's say it said graph 6y equals 5x minus 6, right? Graph 6y equals 5x minus 6. Now think about what we've talked about how to graph. We only know 2 ways right now. One is to pick points, right? The homework had you do that a few times where you would take a table, you would just pick a bunch of x's and then find out what went with each y, right? That's fine, except it's kind of a pain. You'd have to put in 1 here, you'd have to solve for y. There's a lot of work there. It's possible though. The other way we solved was, or to graph, was to use y equals mx plus b. And I think you'd agree this is the one everybody prefers. So wouldn't you agree, if I could get 6y minus 5x equals 6 to look like y equals mx plus b, I could just graph it. So that's the idea. When they tell you to graph something, well, I'll say previously, but in this class anyway, previously, everything has been in y equals mx plus b format. Not any longer. Now we've got this ugly thing, 6y equals 5, 6 minus x. So how can I take 6y equals 5x minus 6, I think I just said that weird a second ago, 5x minus 6. How can we get this to be y equals mx plus b? Doesn't that just mean getting y by itself, solving for y? Well, how would you get the 6 off the y? Wouldn't you just divide by 6? Now there's 2 pieces over here, so make sure you divide by 6 to everything. So on the left side, you just have y. And on the right side, you have 5x over 6, or 5 over 6x, whichever way you like to write that, they are the same, minus 6 divided by 6 would be negative 1. And now it's y equals mx plus b. So if you are given an equation and it's not in y equals mx plus b, now you know how to solve and get it into y equals mx plus b, and that's the point. So our slope is 5 over 6. Our b is negative 1. We can go ahead and draw a rough graph of this. Rough, it's not going to look great. So our graph should start at negative 1, something like right there. And then our slope, 5 over 6, they're both positive, so that should be up 5 and then right 6. So up 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5, 6, somewhere about there. I'm not saying it's perfect, but something like that. Now you have your line. So rather than having to go through the table method where you got to pick an x, plug it in, see what the y is, pick an x, plug it in, see what the y is, pick an x, plug it in, see what the y is. If you can take an equation that's not y equals mx plus b, get it into y equals mx plus b, then you just graph it like normal. And that's the idea. That's the point, y'all. I want you to be able to take an equation that was not in the format you wanted it in and get it in the format that you wanted it in. Let's do one more of those just to make sure we're on the same page, and then that'll wrap it up. So let's say I said 5x minus 3y plus 12 equals 0, and I just told you to graph it. Well, remember, you could just make a table. Like we just said, pick an x, plug it in, see what you get for y, pick an x, plug it in, see what you get for y, pick an x, plug it in, see what you get for y. But that's a lot of solving work here. I'm not going to do that. I'm going to try to get this to look like y equals mx plus b, and then I'm going to graph it. So 5x minus 3y plus 12 equals 0. And I want it to look like y equals mx plus b, which means I want to solve for y. So I want this y by itself. So that means I need to get rid of this 5x, I need to get rid of this 12, and I need to get rid of the negative 3. First thing to me is just get rid of the regular number. I'm going to subtract 12 from both sides. So that gives me 5x minus 3y equals 0 minus 12 is negative 12. That's looking better already. Next thing I want to do is get this piece that's not attached to the y. Let's move the 5x over there. It's positive 5x, so I'm going to subtract it. Remember, I'm not trying to split the 5 and the x up. Be careful how you do this. You're trying to make y equals mx plus b. So on the left side, you have negative 3y. On the right side, you have negative 12 and negative 5x, which are not like terms, so they're just both going to sit there. But put this in the correct order. You want the x part first, so put the x part first. Then put the b, right? It's up to you which order you write those in, so put them in the order that looks better to you. Now we need to get y by itself. So I'm going to divide by negative 3 here, here, and here, leaving us with y on the left side equals negative 5 and negative 3 is positive 5 over 3 x. Negative 12 and negative 3 is positive 4. So now we have y equals mx plus b, y equals 5/3 x plus 4. Our slope is 5/3. Our b is 4. Hopefully I can squeeze that in here. These are actually not looking terrible. I say that, but then my line's going to look crooked. So this one starts at 4. 1, 2, 3, 4. A lot of y'all were starting your lines on the wrong place in the test. Be careful. And your slope is positive 5 over 3. So that will be up 5, right 3. Let's go and extend the graph a little bit. Up 1, 2, 3, 4, 5. Right 1, 2, 3. Should be about right there. If you have graph paper, it'll look beautiful. And there's our line. So if they're asking you to graph something that doesn't look like y equals mx plus b, turn it into y equals mx plus b, and then just graph it the way you're used to doing it. That's the point, y'all. That's the whole idea of this lecture. Yes, it's about solving. We did a bunch of different equations and things like that, but ultimately it's coming back to graphing. Your third test is 80–85% graphing. Make sure you're comfortable with this before you move on, okay? And I'll see you guys in the next one.